Hi, good morning, everyone. We're going to start the webinar right now. So, hi, everyone. My name is Tim Hunter. I'm president and founder of Wolfstar Technologies, and we're kicking off this first of this four-part series on dynamic load understanding and the impact of structural loads on product development. So, this will be a pretty exciting topic for us to talk through today, and we'll get right into it. These are just short webinars; they're just 30 minutes. So, we're just going to be touching on very high-level topics today, and we'll get into things. Okay. So, um, as so to get right into it, this is called ROI on Overdrive. So, mastering your virtual product development for for unprecedented results. So, a little bit about me. I'm Tim Hunter. I'm founder and president of Wolfstar Technologies. Um, I founded Wolfstar back in 2010. We've been going on 13 years now, and I'm the president of the company. And prior to that, I was 22 years at Harley Davidson. I was chief engineer of vehicle structures, and I understand every aspect of product development. I've been through it all. I've worked with styling to get concepts launched into production. I've worked with manufacturing. I've dealt with warranty issues. I've dealt with safety issues. I've done it all. I've been there, done that. I understand what you all go through. Um, uh, and some of the technical accomplishments I've done is I developed topology optimization before there were commercial topology optimization tools. For my PhD dissertation, I developed a novel methodology for metal fatigue, doing FEA-based fatigue analysis before there were FEA-based fatigue analysis tools. And I developed true load reconstruction, and I decided to take that to market. So that's our flagship product. So true load reconstruction. Um, and the tool sets that we use at Wolfstar, we use the standard FEA tools out there: FEMAP, Abacus, Siemens SimCenter, ANSYS. We use FE-Safe for doing durability analysis, and then we've got our own fatigue tool called TFU Fatigue, and also obviously our TrueLoad suite of tools. So this is kind of all about me and the technologies that we bring to bear on the market. Um, so what are the product development ROI drivers? You know, the number one thing here that we're all dealing with is time to market. We all understand we've got to get our products to market on time, and if we can get them to market earlier, it's better for the business. So it's all about time to market. So we all understand that. That's business 101, right? Um, but then, as an engineering team, we get caught up into this design, build, test, repeat, because we'll go to the proving grounds, something will fail, and then we get this failure in the proving grounds, and we come back to the analysis team, and they will struggle for days, weeks, maybe months to try to simulate that failure in the proving grounds. And then you get back to the proving grounds again, and it happens again. And so you're in this endless cycle of design, build, test. And this is just puts a drag on the product development cycle, and frankly, impacts your time to market. And the third thing is that, you know, engineering ends up taking the blame. Okay, engineering is the only department at your company that has to answer to physics. Okay, finance, marketing, sales, they can say things, and then when they don't turn out, they can change what they said, and away they go. Engineering is the only part of the company that has to answer to physics. Physics isn't going to change for us, okay? So, and because of that, engineering ends up being one of the largest cost centers, and engineering ends up being seen as this big drag on the company because it's a large cost center, and engineering ends up saying no a lot. Okay, we end up saying no because there's failures in the field. We can't deliver the desired feature marketing wants. So engineering ends up saying no a lot, and we get seen as being this hindrance to the company. And we end up being the black sheep of the company, and it's just kind of this this good bad that you have as an engineer is that you can do all these things, but you've got to say no a lot of times too. So this is just what happens with engineering, okay? And we should figure out ways that maybe we can change it around a little bit, okay? So maybe we can do that. So um so the this is a typical product development curve that we go through, right? So you've got this target cost for your product development, and you've got this time that you want to commit to your tooling for production and release to market. So this is kind of how it goes. You're going along, you get a failure, you get a discovery about your product kind of late in the program, you react to it, and then you're coming right up and you're commit to tooling and you've got a failure there. And oh my God, you're scrambling and you're trying to make it to launch, but you get another failure and you miss launch, and now you've got to move your release tooling and your launch date. So you miss it all, you've spent a lot of money. And what you really want is something looks like this. Here we want to put some investment on the front end. We want to maybe do some learning in the proving grounds early on. We can take those learnings in and then we can use it to influence our product, do a couple more learnings in the proving grounds. And this is a learning cycle and we're making our product better and better. And guess what? We can move our launch dates up. Okay. If we do this right, we can actually launch early and not late. And this is really what we want. So we could have this or we can have the way we always do it. Okay. And I have done this red curve several times, and I have done you know, the working 18-hour days for 6 weeks going up to launch. I know how it goes. Okay. We all go through these things, and there's got to be a better way. Okay. Frankly, there's got to be a better way. So how can we go from bad to good? Well, there are things that are out of our control, largely things like funding. And there are things that are in our control, things like how we leverage tests and analysis and our product development. And then there's stuff right in the middle that's all about our requirements and working with the rest of the organization. So there's things that we can control, things we can't control, and things that we can influence. I mean, this is kind of where we end up with, right? And and so this is just personal experience on my end here. Funding, okay? I have had actually at least two product programs that I can remember where it took forever to get the executives to sign up funds for the program so I could go off and do things. So to get the 4 or 5 signatures I needed on a piece of paper to give me the funds to do what I needed to do, it actually took longer to get those 5 signatures than it took to implement a 16 million robotic weld line. Okay, think about that. 5 signatures versus 18 months of a product of a tooling program. That's how long it took to get funding, and because it took so long to get funding, this delayed testing and procurement of prototype parts. And because we had those delays, we were learning things very late in the program, and we had these learnings late in the program. Um, we ended up having to push right up against the launch dates and even miss some launch dates because of that. And then when you sit down at the after action reviews and all this whole thing, you sit down with the after action reviews and you look at the program, somehow engineering was to blame for why the executives didn't put their 5 signatures on a piece of paper. Okay. So this happens, and I know this is how politics goes inside of companies, that they got to blame somebody and they're not going to blame the executives. This is how it goes. Okay. And this is just one of those things that we've got to influence and try to change if we can. And really, we got to get our senior engineering leadership to commit to this. Is that basically we've got to basically get commitment to funds on day one that the corporation decides to commit to the program. And it's amazing how things happen in companies is that they'll decide to do a program without letting loose the funds needed to do that. So my number one advice here, if there's any way that we can do this, is that we need to drive to get our senior leadership to commit to the funding before programs ever started. Okay. And if they don't, we shouldn't start the program. We should push back and say we're not going to start until we have the money. All right. Um, and another thing is requirements. Okay, requirements are really super hard to set. I fully understand it, but we really need to set up a collaborative environment where we're doing that. So we need to be working with the marketing folks. We need to be working with the voice of the customer folks for our requirements. But it's extremely important for engineering to bring in their most talented folks in setting the requirements on this stuff. So you got to actually get people with gray hair in on these things, people who understand the full breadth of the product, people who understand what you can and can't do, and can sit down with these stakeholders and have good interactive conversations, trying to give them what they want, but while having it reasonable and doable for engineering. And oftentimes, requirements are set up so that they're self-conflicting. People want to have want to have the lightest vehicle possible, but have it go as fast as possible. Well, those things are just uh, counterintuitive. You can't do both of those things. So you need to have realistic goals, and you need to have it done in a cooperative fashion. And really, a key here is to bring in some of your best engineering talent when you're sitting down working with marketing, and to really to take the voice of marketing and voice of the customer, turning it into engineering tools. And then as you're doing that, you need to actually plan for iteration. Okay, you know, it is so important in an engineering program that you plan for learning things and going back and iterating. Okay, if you make a product, if you make a plan for a product, and it's just a Gantt chart from start to launch with no space for iteration in there, you're just planning for failure, because you will learn things, you will go back, you will have things that conflict with requirements, and you're going to have to iterate. Okay, that's what engineering is. And if you don't plan for that iteration in your product plan cycle, if you don't make room for it, you're just setting yourself up for failure. Okay, you've got to make sure that there's room for iteration in your product, in your planning. And and these requirements have got to be clear. um, you've got when you get done setting requirements, you've got to make sure these requirements have got numbers on them, right? Engineers need numbers that they can go to. So you got to take these very wishy-washy things coming from marketing and voice of customer, and turn them into numbers that you can meet. So it's really important that you do that, and really important that you track that. Okay, these are all these are all things that take work on the front end, but if you do that right, you're going to have a much cleaner execution of your product and your product launch. Okay, so this is just good for everybody. Um, and you want to, and these are things that we can do on our own here. So defining proper analysis models. So analysis is key to doing product development these days, and I'm sure everybody here knows that. But when you start off a program, you want to gather your in-house analysis tools and experts. So you want to go out and survey the best tools and best experts you've got in-house, and these can be commercial tools. They don't have to be homegrown, but they've got to be the best tools and experts you've got, who can come in and help you out with your program. You've got to get those guys on the front end here. And is really important is to start off with high level simple models. And this, I know this can be a little bit counterintuitive, because we've got all these fancy CAD tools and fancy 3D modeling tools and stuff, but you learn so much just by having stick figure models. So have lump mass spring systems, just have things where you can very quickly play with parameters and quickly iterate on high level values. So, set up a spring mass system, set up beam models, set up very simple, very kind of hand built models that kind of represent your systems, that will allow you to very quickly and easily iterate over high level parameters on your parts, so you can set an overall design direction. Okay, this is super important here. And then once you've gotten past those initial high level, simple models, then very quickly you need to get into 3D design. So I'm not saying don't do 3D design. So definitely, 3D design is where it's at. So definitely, to make this be as effective as possible, you want to have your analysis team and your design team co-located, because if the analysis guy is sitting right next to the design guy, the analysis guy is going to be committed to the program. They're going to be just as committed to the design guy, to making sure that these things happen. And what you're going to find is that the design guy is just going to have some some kind of what if ideas he comes up with, and he'll just talk to his buddy sitting next to him, and they'll play that out in analysis very quickly. Whereas if the analysis guy was sitting down the hall, well, now it becomes a request, and you got to walk down the hall, and then that spontaneous reaction is never going to happen. So it's so important to have these design folks and analysis folks co-located and committed to the program. Okay, it's very, very important here. And And what's going to happen is that this design and analysis interaction is going to become very interactive and iterative. And so the design guys and the analysis guys are going to be working on these things in a very tight, dynamic fashion. And this is going to give them, really great results. And then by all means, when you're in this format here, you want to be leveraging obviously FEA, but you want to leverage topology optimization and parameter optimization. These are the things that are going to give you the lightweight, innovative structures that are going to give you the designs that you want to bring to the marketplace. Okay, so these are really important tools to have on the table and to bring and to fill what you want. So here we are. We're starting from lump mass spring models going to full 3D CAD design and mesh models to topology optimization, and you want it all. You got to do it all. Okay, it's just it's part of all the tools in the toolkit there. And then finally, you need to make sure you've got sufficient computational resources. There is nothing more costly than having an engineer and analyst wait for results. Okay, you can't have them waiting a day, a week, 2 weeks for models to solve. You've got to give them very efficient computational resources. So you either got to have a compute farm on site, or with all these cloud-based computing resources that are out there, there's no excuse for not having, um, you know, the best computational powers available. And these are all things, and this is all going to be an upfront investment. It's it's going to be an upfront investment, and it's going to be something that you're going to have to invest in on the front end. Okay, and this is part of the reason why you want to have the money on the front end. So if you need to go and get some tools, some compute resources and things, you're going to do them on the front end so you can leverage them on the front end. Okay. And you want to understand your product loading. Okay, product loading is critical to understanding your product design cycle. You're going to have these beautiful 3D CAD models, beautiful 3D meshes, beautiful analysis tools. But if you're guessing at what the loads are on the FEA models, you're guessing at the results, and you're going to just end up iterating. Okay. So if you're doing a clean sheet of paper thing, you might want to use multi-body dynamics, okay? That might be done if you've got a clean sheet, never before done concept, okay? But I think these kind of never been done before things are very, very rare. Most of the things that engineers are working on, they're either revisions to last year's model or uh, or a competitor's product. So you're going to have, an operating mule, you'll have previous model, a competitor's model. So you'll be able to on these existing physical prototypes you've got, even in the very early concepts, you'll be able to do load reconstruction to get the actual operating loads on those things off your proving grounds. And those loads then can drive your modeling and design decision. Okay. But this is an investment. Okay. You've got to invest in FEA on these things on the front end. Okay. So you've got to go through that and make that investment in the FEA. Okay. And and uh, and then but if you do that, if your engineers end up knowing the actual operating loads, the engineers are actually going to make the right decisions. Okay, engineers aren't dumb guys. Okay, engineers are probably some of the smartest guys you got in your company, but they end up making mistakes on their design decisions, not because they don't know what they're doing. It's because they didn't have the proper loading input to make the design decisions. So if we give them tools to get the loads so they can make uh, the right product decisions, you're going to end up going through the design build test cycles fewer and fewer times. Um, just a personal story. When I first introduced this idea of load reconstruction at Harley Davidson, the product programs we typically did would go through 6 major design build test cycles. And the first one I introduced that on, we went from 6 design build test cycles down to 3. Okay. I mean, it just works. Okay. If you can understand your loads and what you need to do, you're going to have to iterate fewer and fewer times. Okay. So this is just part of making sure that you're as efficient as possible in deploying your resources. And then you want to get the most out of testing, okay? the testing organization has got to help you explore engineering concepts. Okay, they're another one of these tools that can help you understand things. Okay, they're not a punishment box for your products. They're a tool that you can help you understand and explore concepts. Okay, so you want to really leverage the test organization with this whole idea of load reconstruction. Okay, and for the test organization, this this is a really simple way to do things, because with load reconstruction you're basically using uniaxial strain gauges. Okay, so they're just going to be laying uniaxial strain gauges in nominal areas, and they're going to end up minimizing your test cost, because a strain gauge costs $10 versus buying load transducer, which costs thousands or tens of thousands of dollars. So they're just going to buy a bunch of $10 strain gauges and put them on your structures, and then by leveraging load reconstruction, you're going to have uh, operating loads that are mapping back to your FEA models, and the analysis guys are going to be working with the test guys really closely, because they can't wait until get those results back to drive their models. So you kind of get this kumbaya relationship going on, where now you got the analysis guys and the test guys working together to get the answers to understand your product design uh, parameters. Whereas oftentimes it's just the opposite inside of companies, where the analysis team and the test organization are at odds. This kind of load reconstruction methodology puts them together, because they're solving the same problem together. And this is going to actually make a better, smoother way to get into the test organization. And by all means, please do not get stuck in this habit of breaking parts in the lab. I know engineers where it's very comforting to have a broken part that you can bring into a meeting and sit down in front of the VP of engineering and say, oops, this broke in the lab, we got to fix this. And then you create a panic attack inside of the organization. And so now you've got design engineers and analysts spinning their wheels to reproduce this this uh, this thing that broke in the lab somehow. And you're just kind of iterating on this thing. And this may not even be a realistic failure. This might just be a failure that was just an overload in the lab because of a bad design, a bad lab experiment. So don't get stuck breaking parts in the lab. This is, you know, this should not be the goal of bringing something to the lab, is to break apart. Okay. The goal of working with the lab is to learn about your product, understand the loading, and do the right things to design out failures and have the proper understanding of your products. Okay. So these are kind of the high level things I want to talk about today. And really what we want to do is we want to enable this curve, right? And what I just talked about was, you know, getting commitment to your funds early on, doing some early learnings here with load reconstruction, and then you driving those analytical models so we can iterate and then eliminate our um, our design flaws, and be able to get to a point where we can launch our product early and actually become the heroes of the organization. We can do this. Okay. This is something engineering has got the capability to do, and we can get there. And I think with just a couple of good planning and a little pushback against the organization, we can enable a lot of good things to happen. Okay. This can make all of our lives better, and we can be the heroes of the organization. Okay. Actually, engineering got superpowers, so we might as well show the company that we're the superheroes we are. Okay, thank you all for joining us today. I'm really glad you all could come in and make this. This is the first of our 4-part series. Our next one's going to be on October 11th, and it's going to be harnessing simulation and test and product development. And we'd love to see you there. We'll really kind of do a deep dive into some of these simulation and test ideas that we're talking about here today, and it's really going to give us some good tools here. Um, and uh, and um, we'll definitely uh, 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 take a look at trying to get some information to you. If you've got any questions, you want to get back to us, please, you can get back to us. I know you've all have got emails from us, so either email me, tim.hunter@wolfstartech.com, or susie.ralston@wolfstartech.com, or cindy.murphy at wolfstartech.com. All of our emails are on our website, and please reach out to us. We're happy to answer any questions. And that brings us to the end of our webinar today. Okay, so thank you very much. This was great. I'm glad to share these thoughts with you, and we look forward to getting back to you. We will have a recording for this, and we'll make sure we get you the links to that recording shortly. Thank you, Owen. Goodbye. It was great.